Who watches the watchers? That's the famous quote about monitoring people who do the monitoring. Well, if you'll allow me to butcher the English language just for a second, you could almost call this episode How Watches the Watchers. In this week's streaming audio, we're taking a look inside New Relic, who use Apache Kafka to provide a monitoring service at, frankly, an astonishing scale. And Anton Rodriguez is going to tell us about the project he's been working with to monitor those huge Kafka clusters themselves and get some insights out that I wouldn't have thought possible. Or at least I wouldn't have thought practical. And sometimes that's the most important difference, right? Before we start, let me tell you that the streaming audio podcast is brought to you by Confluent Developer, which is our site that teaches you everything about Kafka, from how to start it running and write your first app, to systems design and monitoring. Check it out at developer.confluent.io. And if you want to take one of our hands-on courses you'll find there, you can easily get Kafka running using Confluent Cloud. Sign up with the code podcast100 and we'll give you an extra $100 of free credit to get going. And with that, I'm your host, Chris Jenkins. This is Streaming Audio. Doors, floors, drawers. Let's go. My guest today is Anton Rodriguez, who is the principal software engineer at New Relic. Now, I know New Relic as a big monitoring platform, but I'm sure he's going to tell us a lot more under the hood than that. Anton, thanks for coming on.
Thank you, Chris. Big pleasure to be here today. Big pleasure to see you in the Streaming Audio podcast.
Thank you.
Podcast is a source of inspiration for all of us. Really happy to see you moving it forward. Continuing with the amazing work team was doing on that.
He did a great job with this podcast, and it would have been a tragedy to let it drop. So I'm doing my best to fill his shoes.
Sure, you're going to do it great.
Thank you. So let's start with where you're at. So you're the principal software engineer at New Relic, and New Relic is, I know them, they do monitoring. And I know they do monitoring at scale, but give me an idea of what kind of scale we're talking at.
Yeah, okay. Yes, New Relic is all about monitoring. Because of that, we have customers around the world, a lot of them, and all those customers are sending metrics, logs, and all that type of information to us. So we ingest a huge amount of information. Just to give you some numbers, which I think are good to understand the scale. We ingest around 125 petabytes of data per month. That's around
125 petabytes.
Petabytes, yeah. It's pretty crazy. I mean, I'm sure there are other companies doing similar or even more, but at least with my experience working with Kafka, it's a lot. And many of the best practices I typically use in other places doesn't work here because of that. We need to move some of those things to the next level to make things work at that scale. It's just thinking how many messages we ingest per minute. It's around 3 billion of them. So just during this minute, we are ingesting a lot of data.
That's insane. Like, I imagine everybody listening to this has had a server go down because one of their log files filled up. But you're filling up like a whole rack full of stuff in minutes, seconds.
Yeah, it's a lot.
Okay.
Because of that, we started like in many companies with a single Kafka cluster that was growing a lot. At some point, we have more than 275 brokers. Wow. It was very painful to maintain and to operate that thing. So we start with what we call a cell architecture, which was basically split that huge cluster in smaller pieces and deploying them in the cloud. And that's working much better for us, but it's also introducing other challenges.
Just out of interest, how do you split it? Do you group together customers, and what's the logical split of cells?
Basically, we do it with two different things. One is customers, so we do sharding based in accounts, and in that way we can move a specific account to a specific cluster, and also data type. So we have different types of data like metrics, distributed tracing, logs, events. So basically, we use both things to try to speed the load to make sure. The good thing about this is if we have a specific problem in one of our Kafka clusters, it shouldn't affect the rest of the data of that particular customer or other customers. So it allows us to have some level of isolation for our customers and to make sure things work for them all the time or almost all the time.
That makes sense. So okay, so that's your first level of I can see how that would introduce management problems. Take me through it. What happened next once you split that up?
Yeah, that's the thing. Because there are two things here. First one is now we work with a lot of Kafka clusters at the same time. So the typical thing I was doing in the past, where you have one Kafka cluster and then you add a new one and you are configuring specifically every cluster for the traffic, that's just not possible. Now we have more than 100 clusters. We cannot go cluster per cluster, optimizing for the traffic of that one. So basically, we group them for functionality. Like, for example, a group of clusters for ingestion, and all those clusters have the same configuration, the same topics, everything is the same. So if we change something, we change something for all of them, which is really good for be able to manage and operate those clusters, but at the same time introduces new challenges in the sense of maybe because the traffic is slightly different between them, find the right spot, the right configuration for all of them. It's much more complicated.
But you're splitting it logically, so hopefully there's something common to all your ingestion things that will sort of work out, and something common to all your consumer end stuff.
Yeah, there are things we can use, but and we use them for sure. But there are also things which make things more complicated. Like for example, the accounts, our customers. We have really big customers, which is slightly difficult to move them, and we have other customers which are smaller. So put everything together and to make sure they work without affecting ones to another ones. It requires some configuration. We need to have Kafka quotas in place. We need all our infrastructure being able to react to changes in real time and to adapt to those situations. And that's another of the challenges we have is all those clusters of our cell architecture. In any moment, we can add new clusters or we can decommission some of them. So all our tooling, all our processes need to be aware of that because it's just this cluster is not going to be permanent. In any moment, we can just decide to decommission it or create a new one, and all the traffic can be affected by that. Our customers shouldn't notice all those changes under the hood. So that introduces also some challenges how we operate and things which are not so typical or some usual in other places.
Yeah. And meanwhile, you've got all your customers, presumably some of them at any one time, they are expecting to be able to see in real time the data that will solve their problems and their production issues. So you've got to be really transparent underneath their surface, right?
Yeah, it has to be. It's just, of course, they want to go to New Relic and have those dashboards and see how the data is receiving. But even more important for us is most of our customers have alerts based in the data. So if any specific software stops reporting data, they want to receive an alert saying, hey, your service is not reporting data. So we need to have all the logic in our pipelines to detect that type of situations and generate those alerts. And we need to do it at the scale of 3 billion messages per second. So
yeah, and in real time, right?
Yeah, it's near real time. It's not. We don't have such strong requirements in terms of latency. Thinking, for example, in an alert, it doesn't matter if the alert, if we launch the alert like a couple of seconds later. That's for most of our customers is just okay. So we have some, room we can play with in terms of latency. There are other places, other people, other companies with stronger requirements on latency. In our case, it's more about manage all that throughput, all those messages. We have some requirements in latency, but they're not so strong as other places have.
Well, you say that, but I sometimes think you can divide the computing world up into what they consider a long time, right? 2 seconds, that's pretty fast. Some people think 200 milliseconds is slow. Some people think a week is fine, and we're not in that place. Right?
Yeah, well, a week for sure is not okay for us. I'm not sure our SLAs specifically.
But 1-2 seconds we're
I think for most of our, for example, I was working a lot with the logging team, and in a couple of seconds we have all the logs already ingested in most of the time. And it works pretty well. I know it's slightly faster than other competitors. Yet, as I said, I think it's just not like the most important thing for us. From our customers, is more reliability and being able to to define and to process all that information to really have a nice UI, which it's able to make sense of all that data. Than the really how fast we ingest. That's important, but it's not the first thing. That's my opinion. To be honest, I don't work with our customers normally. I'm much more focusing our platform.
Down in the mines.
Yeah. So, and I'm of course, we are a heavy user of New Relic because we use it for monitoring.
I was going to ask. So, you must have a huge monitoring problem of your own. Do you eat your own dog food? And how does that work out?
Totally. And I have to say that's nice because the good thing is we can monitor as much as we want. So, in other companies, I have that thing of, hey, this is expensive. Please don't send so many metrics. That's not happening here in New Relic. I can use as much as we want. We have very good monitoring in place, which allows us to operate Kafka at scale. Some of those pieces are already open source, so other people can use them too. And we are also working open source even more of them. So that's something I like a lot. And one of the things also is before to make any change in our production environment, we do it in our own monitoring environment. So each time we change something, we are using it and we are confident enough to deploy it in production later because we see that's working for us. Because we are our biggest account, it's going to work for others too.
Yeah. It's always a great way to get a feedback loop if you can be the user of your own service, right?
Yeah. Definitely. I recommend it for everyone if you can do it.
Maybe I should put myself on the podcast for the same reason.
I think Chris interviewing Chris will be awesome.
That would be weird.
Well, maybe you can ask Tim to interview you as
oh God, yeah, that would change things up. We'll have him back next year once he's got his feet settled somewhere else. See what he's been up to. So along the way, you must have had some new insights into how to do this monitoring stuff at scale.
Yeah, one of the interesting things I wanted to share is eBPF and Pixie.
eBPF.
eBPF, yeah. If you're not familiar with it, eBPF is a new Linux capability. It's something we have in the kernel. Okay. It's pretty new. It's not this year, but it's pretty new yet for many engineers. Basically, it's allow us to retrieve information directly from the kernel with a very low overhead and in a very safe way. In the past, when we wanted to have information directly from the kernel, it was kind of risky because the Linux kernel, it's a core component. If we break something there, we are going to create a big mess. But with eBPF, it's just slightly different. We can access to all that information almost in a very efficient way and without making any type of problems in the kernel.
What kind of stuff can you read out of the kernel from eBPF?
Basically, almost everything you have in the kernel. you can detect each time an application is open a file or open an external connection, or for example, some of the things we are doing right now, it's each time an application, a Kafka application or broker or the client, it's receiving a package, network package. eBPF is able to retrieve that package, to send it to other programs to see what we are doing in Kafka, and then continue the process. And we can do that very efficiently. So it's not affecting latency or the throughput or anything like that. And then what we did with Pixie is make this software able to understand Kafka, the Kafka protocol, to not only have monitoring, but monitoring specifically for Kafka to understand what's happening. So things which typically we cannot have easily with Kafka because we need extra software and we need to really understand how it works. Now with Pixie is really easy. Things like being able to measure the consumer log, so how many messages we have pending to be consumed by a consumer.
Really?
Yeah,
You
we
can
can
get
do
that from a
that
kernel
in
level
much
tool?
different way. Yeah, directly from the kernel. And this is, in the past, when we want to do this, we always needed an extra software. There are open source things like Burrow from LinkedIn or the Kafka Log Exporter for Liveman. But this is just something you deploy in Kubernetes, Pixie. It doesn't matter where are your customers, where your applications, what technology they're using. It's able to retrieve all that information, make sense of it in the context of Kafka, and show it to you in a very nice way. So for me, I discovered this 9 months ago when it was open source to the Cloud Native Foundation. And it was, for me, was mind-blowing, all the things you can do, which was not possible in the past, and how it's just not the typical monitoring we have for Kafka. It's just totally different because it's like external monitoring. So I'm very excited with this. I'm providing a lot of ideas to the Pixie team to build new use cases. But I am even more excited to share it with the Kafka community to see what ideas have the Kafka community to use it in their own projects and use cases. Because pretty sure because it's so new, it's so different, we're going to find quite interesting ideas out there.
Yeah. I'm going to need you to, maybe this will stimulate some ideas. I'm going to need you to draw the line for me, because I think of like kernel space as down here and application space up there. Draw the technical line for me that gets me from monitoring the kernel to actually seeing how many pending messages I've got in the consumer, because I can't draw that line.
Yeah, that's a good question. So basically, we are using Pixie. Pixie, it's as I said, it's a new platform. It's open source, part of the Cloud Native Foundation. What we do is you deploy Pixie in Kubernetes. Pixie, what is going to do is use eBPF in all the Kubernetes nodes to understand what is happening and send all that information, all those metrics using eBPF to a shared database. So with Pixie, we have information about what is running in Kubernetes, how much CPU they are consuming, the throughput, all that information.
Open file handles, all that stuff.
Yeah, whatever we want, really. Yeah. I mean, whatever, no, but almost, many metrics. We have a lot of information. And because it's just not depending of the applications themselves, it's using Kubernetes as a standardization layer. Those applications can be in Java, in Go, in Rust, in wherever. But Pixie, because it's just retrieving all that information directly from the kernel, using eBPF, it's able to send all that information. And, you have like a standardization of the information for all the applications.
Right.
And then we have in Pixie, you have all that information, but you have also the possibility to create scripts to create your own dashboards and to modify and aggregate the metrics you are receiving. So basically what we are doing in Pixie is adding scripts specifically for Kafka to make metrics aware of the context of Kafka and show specific information for Kafka. Things like consumer log or rebalances or just the discovery of clients. Some of the problems I have right now is because we have so many clusters and so many clients. It's not always easy to identify the applications consuming or producing with Kafka. With Pixie, you just deploy it in Kubernetes, and it's going to list you all the applications consuming or producing to Kafka and the throughput of them, and you are going to have all that information in just with a couple of commands. That's awesome.
But okay, so you say consumer lag. Does that mean we're getting the difference between the topic's offset and the consumer's offset, or?
Yeah, it's slightly similar. That's how we typically measure consumer lag. What we are doing with Pixie is it's tracking each time a producer is sending a message, and it's tracking each time a consumer is reading that message, and it's calculating the difference in time between those two actions. So if we have a producer sending a message, the consumer, because it's reading a lot and it's not able to read at the same rate, it's taking longer and longer and longer. Pitching is able to say, hey, now for the maximum time a message is waiting to be consumed, it's wherever and it's able to provide us in time, which is usually much more useful than in offset as we typically have in the Kafka community.
Yeah, I can see that. So is that tracking? Is that tracking every single message, or are you just sort of sampling?
It's tracking every single message, but it's most focused in the part of the Kafka protocol. So each time we have a consumer and the broker, they are sending control messages. So with Pixie, what we are doing is tracking those messages to have information and to make that information. So we don't need to track all the data flowing because it could be a lot, but we're specifically tracking the control messages. This is very interesting, for example, for rebalances. When we are adding a new service reading to Kafka, it's typically need to coordinate with the existing services in what we call the consumer group. And that's what we call a rebalance. And it can be quite costly for Kafka in the sense of that coordination may affect the throughput. So when that's happening, all those clients are sending messages to the broker. What we do is we retrieve those messages to understand what's happening and to be able to really provide information and context about that. And that's something, in my experience, quite hard to do until now, because you need to have information in the broker side and in the client side. Put all together is not easy. But with Pixie, because it has access to both things in the same way, it's much easier.
Yeah, and you don't need to make sure that you're aligning languages, presumably on each side, right? It's completely transparent to the application layer.
Exactly. It doesn't matter if you have it consumer in Ruby or Java or Go, they are going to work all in the same way because you are really not taking a look inside those applications, but how they communicate with Kafka. So it's a totally different approach. And that's why I think it's so interesting, because we are looking at a typical problem with a total different perspective.
Yeah, that's nice. I can see, especially for a company. How many people are you? You must be...
I don't want to lie, so...
Give me a ballpark.
I'm not sure. I really don't know. I think in engineers, we should be around 2,000 or 3,000. Yeah. That's the number I have in my mind, but it could be totally broad, to be honest. I'm really more focused in the technical side of things and not put too much attention. I'm pretty sure they repeat that to me many, many times, but I'm not able to put that information in my head.
But you're definitely in the scale where you can't make every engineer... Realistically, you can't say everybody does it this way so that we can monitor you. You have to have a solution that's transparent to that.
Yeah.
That's nice. You discovered this 9 months ago, you say, and you have been putting it into production.
We don't have it in production right now, basically because how we have our own services. We are in the middle of a migration, and because of that, we are taking some time to put that in production. In this moment, what we are doing is more, from at least from my side, it's exploring the technology. What I have been doing is have regular meetings with the Pixie teams to test this technology. Things like, I have this problem of the teams using Kafka sometimes have rebalances, and it's not easy to see what's happening. So the Pixie team say, okay, let's try to use eBPF and Pixie to solve this, and they are creating those new solutions to those use cases. So for me, my approach to Pixie right now, it's more in the side of evolve the technology and make it sure it works with Kafka, and we are able and find things which are typically pain points for me and make it Pixie to solve them. That's my approach right now, more than proving it in production. That's also related to our scale right now. It's just much more complicated for us to deploy this in all our clusters at our scale than probably for another company having less traffic, which could be do it more easily. It's just it should be easier for them.
Yeah, sure. So, but you're planning to you think this is part of the future at New Relic?
Yeah, for sure. I mean, we are using Pixie right now for not only for Kafka, for many other things. So it's there are many engineers really excited about this in New Relic and in other places. And I think also just in the context of Kafka, we are going to find more and more new use cases and things which are really hard to monitor in a different way, and we can easily solve them with Pixie. So yes, I really excited about it. I think it's just pretty new yet, and I need some time, to be more mature and to work in more places. But for sure, I'm totally sure it's going to be part of the future. And I'm sure once more engineers know about it, they are going to find more use cases. Maybe with Pixie, maybe directly with eBPF, maybe with other tools. But it's just, the tool you want to have in the toolset when you are running things in production. It's really helpful.
Okay, so for the sake of people who want to get started with this, let me make sure I've got this clear in my mind. You've got eBPF, which is the kernel level monitoring piece.
Mm-hmm.
Then above that, you've got Pixie, which is both a gathering database exploration tool.
Pixie is the service. So basically, it's making eBPF easy to use for everyone, and specifically in the context of Kubernetes. So basically, you deploy Pixie in Kubernetes, and it's going to put eBPF in every node, all the metrics in every node, so you don't have to go to really that low level. And then it provides to you an UI where you can have all those metrics and build your dashboards. But at the same time, you can also create your own scripts in that UI, and you don't have to really know about eBPF or C or the Linux kernel. It's something very similar to a Python script. So you can write your own there to make whatever you want. You can process information, transformations, things like that.
Give me some gory details on that. What does it actually look like if I want to write a script?
It's pretty easy. You go to the UI. On the right side, you have like an editor. So you just click on that. You make changes, like I want to, retrieve that particular metric, or I want to aggregate those metrics together in once, or I want to calculate the average. Really, I mean, whatever you want to do is super flexible. In our case, we do that too. Okay, I'm going to retrieve the metrics between the Kafka broker and the services. And with that, we are going to, for example, for the consumer lag, we are going to measure the difference between them to calculate the consumer lag in second. That's just one script. You can go to the UI, open it, see it, and if it doesn't work for you or you want to modify it, you can easily change it and then submit it, and that's all you have to do. And now it's working with whatever modifications you added. So it's super flexible.
Okay, and it can retrieve from more than one node. It's a general overview that you can write these scripts.
Yeah, you can. Yeah, totally.
Okay. So I know you're going to be speaking about this at Kafka Summit. Depending on when the podcast is released, the Kafka Summit's April 25th, 26th in 2022. So hopefully that's in your future, listeners. What else are we going to learn from that? Don't give me the whole talk, but what have we missed out?
Well, and in that in the talk, we are going to first of all show some of the challenges when we are monitoring Kafka. Things like discover the clients, things like the consumer lag, things like the rebalances. So explain them in detail with even for people who is not so familiar with those things. And then the second part of the talk, well, we are going to introduce eBPF, how it works, why it's important, what we can do with it, not only in monitoring, but also in other things like network or security. And then what we are going to do is to show a demo of Pixie, measuring all those things. The nice thing is the demo is much more straightforward. It's just much easier to see the demo than explain Pixie. So we want to spend like 20 minutes or so during the talk showing the demo, which I think it's really exciting for engineers to see what they can do and how easy it is to access that information and to build those things right now. Because in the past, to build some of those things was quite challenging and difficult. You need a lot of background in eBPF and C and all that stuff. But now every developer out there can do that. And that's awesome.
Yeah. I have delved into the kernel once or twice, and I think I still have the scars to prove it.
Yeah, even more challenging than it was. I was surprised when I started with eBPF. I wanted to understand how it works under the hood and was doing, some POCs and reading a lot of documentation about it. And it's a whole new world for someone who is more focused in Kafka and Java. It's just too hardcore. At least it was for me.
Yeah. I think I'm happier in application space. Occasionally you have to dive down, but
yeah, it's a very interesting space. One of the things with eBPF is eBPF is running like a virtual machine inside the kernel and have
really?
all that stuff. So in many things are pretty similar to Kafka, Java, and streaming is just not so different because you have that virtual machine. You are subscribing to events from the kernel. You are processing those events in streaming to return them to the user space to do more processing. So yeah, there are many things which are really similar concepts, but there are others which are just totally new for me. How you work with the kernel. Even when I was younger, I was compiling the kernel in my laptop and all that stuff. But right now, it's just
me too. I'm watching it crash, right?
Yeah.
Cool. So I have to ask this to complete the circle. Do you think one day we'll see the output of Pixie going natively into New Relic? Will it be integrated in the future?
It's already partially integrated.
Oh, really?
Yes. I mean, Pixie is a totally independent project. It's part of the Cloud Native Foundation. You don't have to use New Relic at all if you want to use Pixie. But if you want to use Pixie with New Relic, you want to combine all the features and services we have in New Relic with Pixie, you can also do it. So the engineers, many engineers working in Pixie work for New Relic, so I think it makes a lot of sense. So I really like that model of you have like the open source thing with the core and everyone can use it, can explore it. At the same time, if you want to have additional features, you can go with New Relic as a service, or you don't want to host it by yourself, then you have the option with New Relic. I think that's a very good combination. It's similar to what Confluent is doing with Confluent Cloud.
Yeah, exactly. It's you want to be able to get the core of it and access it, but you want the option of like not having to worry about it so much, right?
Exactly.
Oh, very interesting. Well, so last question: if someone wants to get started, what's the first place they should go?
If you go to Pixie, the Pixie website or the GitHub repository, you have there all the information. It's really easy to do the setup and to start to work with it. So it's really not difficult. Anyone can do it. And I think it's the big first step. As I said, the tooling has been really designed to provide a really good developer experience. So you can deploy it in every cloud and start to play with it very easily, just in the context of Kafka or in the context of any other application you wanted to use. So yeah, it's only that. Also, you can ping me if you have questions. I'm always happy to chat about Pixie, Kafka, and all that stuff. I'm quite active in the Kafka community. I'm really happy to have those conversations if someone wants to ping me directly.
Okay, in that case, we'll put your contact details in the show notes.
Sure.
Along with mine, if you want to get in touch with me for any reason too. Anton, this is one of those talks where I just want to go and quit the rest of the day's work and actually go and play with it and see what it's like. But I may have to wait a while.
Let me know. I really would like to have your feedback on it. It would be awesome.
Yeah, it'd be cool. In the meantime, I look forward to meeting you in person at Kafka Summit, and that'd be nice. And if you're listening to this in the distant future, I'm sure his video will be up if you want to go and see it in action. We'll have that up on YouTube or wherever before long. Anton Rodriguez, got to pronounce that correctly. Thank you very much for joining us on Streaming Audio, and I'll see you around.
Thank you very much, Chris. It has been a pleasure.
Cheers. Well, thank you, Anton. He's given me another reason to look forward to Kafka Summit, because I'd really like to see that in action. As I said, the summit is April the 25th and 26th in 2022 in my backyard of London. If that's in your future, I hope you'll consider joining us. And if it's in your past, well, YouTube will probably have his talk up by now, so you can see it for yourself. If you want another way to get in touch with either of us, then reach one of the usual channels. You'll find both our contact details in the show notes. If you're listening to this podcast, we would appreciate a review so that other people can find us. And if you're watching on YouTube, now's a great time to reach for thumb up icons and notification icons and the comment box. Before we go, let me remind you that if you want to climb the ladder from your first Kafka application to processing events at the kind of ludicrous scale New Relic do it, we'll teach you everything we know at Confluent Developer. That's developer.confluent.io. If you're a beginner, we have getting started guides, and if you want to go further, there are blog posts, recipes, and in-depth courses. You'll need a Kafka instance to make the most of it, so consider signing up for an account at Confluent Cloud using the code podcast100. That will give you $100 of extra free credit, which at my exchange rate is worth having. And with that, it remains for me to thank Anton Rodriguez for joining us, and you for listening. I've been your host, Chris Jenkins, and I'll catch you next time.